Imagine opening your eyes for the very first time and seeing absolutely nothing. Not because the universe was dark, but because light itself couldn't escape. It sounds impossible, yet for the first 380,000 years after the Big Bang, this was the reality of our universe. There were no stars, no galaxies, no planets, no constellations, no beautiful night sky. Instead, the entire cosmos was trapped inside a blazing hot fog so dense that even light, the fastest thing in existence, couldn't travel freely. Every photon that tried to move forward immediately collided with charged particles and bounced away. Imagine trying to shine a flashlight through a wall of solid concrete. No matter how bright the beam is, it cannot escape. That was the infant universe. It wasn't empty. It wasn't silent. It wasn't lifeless. It was simply imprisoned by its own extreme heat. But then, something extraordinary happened. In a single cosmic moment, the fog disappeared. Light escaped. The universe became transparent. And that ancient light is still traveling through space today. Scientists call it the cosmic microwave background, or CMB. It is the oldest light we have ever seen. And hidden inside it is a map, a blueprint, that predicted every galaxy, every star, every black hole, and ultimately every planet that would ever exist. Tonight, we're traveling back nearly 13.8 billion years to witness the moment the universe turned on its lights. The universe was once smaller than an atom. It's difficult to imagine just how different the universe once was. Everything you can see today, every galaxy, every star, every planet, was once compressed into an unimaginably tiny state. Then came the Big Bang. Space itself began expanding. Temperatures exceeded billions upon billions of degrees. Matter and energy were inseparable. There were no atoms, no chemistry, only an incredibly hot soup of fundamental particles racing through space at enormous speeds. Protons, electrons, photons, neutrinos, everything collided with everything else. If you could somehow survive inside this early universe, you wouldn't be able to see more than a tiny fraction of a millimeter. Light constantly scattered in every direction. The universe was brilliant beyond imagination, yet completely opaque. This period is often compared to standing inside an incredibly dense fog. Except instead of tiny water droplets, the fog consisted of charged particles, and every photon trying to travel was trapped inside it. The universe was waiting for one thing: time. Cooling changed everything. As the universe expanded, it also cooled. This simple fact shaped everything that followed. Imagine heating a pot of water until it becomes steam. Now turn off the heat. Eventually, the steam cools and condenses back into liquid water. The universe experienced something remarkably similar. For nearly 380,000 years, temperatures remained too high for electrons to stay attached to atomic nuclei. The instant they combined, energetic photons knocked them apart again. Atoms simply couldn't survive, but expansion kept lowering the temperature. Eventually, the universe cooled to roughly 3,000 degrees Celsius, still unimaginably hot by human standards, yet cool enough for something revolutionary to happen. Electrons finally joined protons. Hydrogen atoms formed. Helium atoms stabilized. The charged fog disappeared almost instantly. And for the first time in cosmic history, light was free. The universe takes its first photograph. That first freely traveling light has never stopped moving. It continues racing across space at the speed of light even today. After nearly 13.8 billion years of expansion, that ancient light has stretched into microwave wavelengths. That's why scientists call it the cosmic microwave background. Think of it as the universe's baby picture. When astronomers observe the CMB, they aren't looking at stars. They aren't looking at galaxies. They're looking directly into the earliest visible chapter of cosmic history. It's the oldest photograph possible. No telescope can see farther back using ordinary light. Before this moment, the universe was opaque. Everything earlier remains hidden behind the cosmic fog. The CMB represents the very first chapter we can actually observe. NASA's discovery that changed cosmology forever. In 1965, two radio astronomers, Arno Penzias and Robert Wilson, were testing a large antenna. No matter where they pointed it, they detected a faint background signal. They thought something was wrong. Perhaps pigeon droppings inside the antenna. Perhaps electronic interference. Perhaps a faulty instrument. But after eliminating every possible explanation, the mysterious signal remained. It came equally from every direction in the sky. What they had accidentally discovered was the oldest light in the universe. It perfectly matched predictions made years earlier by cosmologists studying the Big Bang. Suddenly, the Big Bang transformed from an interesting idea into one of the strongest scientific theories ever developed. The universe had left behind its own fingerprint, tiny temperature differences that built everything. At first glance, the cosmic microwave background appears almost perfectly uniform. Its temperature measures approximately 2.7 degrees above absolute zero, in every direction, across the entire sky. But when scientists examined it more carefully, they discovered something astonishing. Tiny temperature differences, not large differences, only about 1 part in 100,000. Imagine comparing two oceans whose depths differ by less than the thickness of a sheet of paper. That's how incredibly small these variations are. Yet those tiny fluctuations changed everything. Slightly warmer regions contained slightly less matter. Slightly cooler regions contained slightly more. Gravity slowly amplified these tiny differences over hundreds of millions of years. Denser regions attracted more matter. Matter attracted even more matter. Clouds formed. Stars ignited. Galaxies assembled. The largest structures in today's universe all began as nearly invisible ripples inside the CMB. Reading the universe's blueprint. Imagine looking at the architectural blueprint for a massive city before construction begins. Roads, buildings, parks, bridges. Everything exists only as lines on paper. Yet those drawings determine what the finished city will eventually become. The cosmic microwave background serves a similar role. Its tiny temperature fluctuations represent the original blueprint for the entire visible universe. Every galaxy cluster, every cosmic void, every supercluster stretching across billions of light years, all trace their origins back to these minute variations. Without them, gravity would have had nothing to work with. Matter would remain evenly distributed. Stars would never form. Galaxies would never exist. Planets would never appear. Life itself might have been impossible. The universe we know owes its existence to imperfections so small they are almost impossible to imagine. In the next part, we'll explore how satellites like COBE, WMAP, and the Planck Space Observatory created the most detailed map of the cosmic microwave background ever made. How those observations revealed the age, shape, and composition of the universe, and why this ancient afterglow continues to guide modern cosmology.